anymore, go ahead and take your textbooks out, put them on top of your desk, but don't open them. We're not quite there yet. How many of you like to cook? Probably some of the girls, maybe some of the guys like to cook in here. I like to cook once in a while. I don't like cleaning up from the mess, so that's why I don't like to cook. But maybe your mom or your dad said, hey, we're having the family come over, or we're going to have a Sunday school party, and I want you to help me cook the dessert, or maybe some cheese dip. I love that Rotel cheese dip that they always have at parties. That's my favorite, but that really doesn't have anything to do with this. Maybe you have your favorite dish, and you like to make it, and you go and you get out your cookbook, and you start looking through to find that recipe, or nowadays you go online, and you find a recipe for those Oreo balls that you like to make. And you see that the serving size for what everything you have is only going to make a serving for 5. Well, if you have a couple siblings and your parents, you're not going to have enough food. So you need to make more. Maybe you have 15, 20 people coming over, and you only have enough to serve 5. Well, you kind of have a problem because you can't be the only one eating at this party. So I know what you're thinking. Come on, you're just going to make it 5 times. Or you're going to times your recipe times 5. Y'all are smart like that. Y'all know it. But did you realize what you just did was algebra? We do algebra every day. Maybe your mom does it at the grocery store when she's trying to figure out for her recipe, or your dad does it when he's at work with whatever he does. Algebra is around us everywhere and every day. So don't let anyone ever tell you that you're never going to use algebra, because you will. So we're going to be learning about algebra for the next several weeks, and so that's what I wanted to introduce to you today. Now, I have a tree up here, and algebra is much like a tree. It falls in line on the math tree. And y'all probably aren't excited about a math tree, but I sure am. So math is the cornerstone. It's at the very top. Y'all been learning math since you were in K-5 when you learned how to count to 10. Well, there are several branches under math. Y'all can probably think of some, but what we've been doing up till now is just our adding, subtracting. All of that is arithmetic. And I'm not going to write the whole thing. We're just going to shorten it to arith. But algebra is what comes on our other branch over here. And that's the branch that we're going to be looking at today. And there are certain things that fall under algebra, and you'll begin to see as we go through this all the things that make up algebra. But there's some very simple things that we need to learn today. So first of all, what we have right here is we would just read this 3xy. But this whole thing actually has a name. And the name of that is called an expression. So what's the name of this whole thing, Hannah?
An expression.
An expression. And it's made up of a couple parts. So we can look here and dissect it, see our different parts. So the first part that we want to look at is this 3. This 3 is what is known as a constant. And I don't know if you guys, you're probably already thinking, well, a constant that never changes. A constant is constantly, it's always going to be the same. So in this expression, 3 is not going to change. We know the value of 3. But we don't really know the value of xy. X could be a number, X could be rulers, X could be chips, X could be whatever you're thinking of, that's what X or that's what Y could be. So those are varying. Those are called our variables. That probably makes sense to you now. It varies. Those are our variables. And you're probably thinking, why can't we just write up there what it is? Well, let's say that I have some coins, and I want to put them all together and figure out how much I have. So let's say I have 10 dimes and 3 pennies. So I could say 10 dimes plus 3 pennies. I know that was excruciating for y'all as well as was for me. So we could shorten this, and we could just say, hey, let's abbreviate D. So we're going to have 10D plus 3P. And we know that D equals dimes, P equals pennies. And then we could work with that later. And we'll be doing that later in this class. But that's what our variables are for. They represent something else. They represent an unknown. So we have our constant, we have our variables, and this goes for any expression. So maybe you're thinking of one. Can you give me an example of an expression, Emma? Any one off the top of your head. What do you want it to be?
4FT.
4FT. She did a great job making that up, because I was going to say that it doesn't always have to be X, it doesn't always have to be Y. Our variables can be any letter, it can be anything. I had a teacher one time who made it a tree. So it would be like 3 in this little picture of a tree. So it can be anything you want it to be. So in 4FT, what is our constant, Anna Grace?
4.
And why is that the constant?
Because FT are variables.
Okay, FT are variables. Tiffany, what are you thinking? Why is 4 the constant?
Because it's the number?
It is the number and it's not going to change. 4 is going to stay the same throughout that whole thing. And FT, why are those our variables, Anna Grace?
Because they could change.
They could change. We don't know what they are. Very good. So we have this, and we're going to work with 4FT now, as long as everybody can see that. What does that mean relating to math? Right now, we just have a number and some letters put up there, and it doesn't really make sense. Well, there's actually an operation. Now, you know we've talked about our operators before. We have multiplication, division. What is another operation, Hannah? Subtraction, and what's another one, Tiffany? Addition. So anytime you see a number and letters like this, or you see 2 letters together, it means multiplication. So we could write this a different way. What's the way that we represent multiplication sometimes, Hannah? With an X. So we want to be careful when we do this sometimes because you don't want your X to look like the variable X. So make sure to note that, So we're going to rewrite this with our X's. So it could be written like this: 4 times F times T. And it means the exact same thing. Or we're going to learn a few more things today. We can represent these multiplication signs with parentheses or with raised dots. So another way we could write this would be 4 parentheses F parentheses T. Or remember I said raised dots. How many of you guys have ever seen a raised dot before? Tiffany's seen one. That's okay. So a raised dot is just a dot. It's not really coming off your paper. I like to pretend that it is, but it's just a raised dot, kind of like a period is in a sentence, except it's in the middle of your line. So we could go 4 raised dot F raised dot T. So Tiffany, give me one of the 3 ways we can use to denote multiplication.
Do you mean like changing it?
Yeah, what is one way we can write it? We can say, Anne Grace, I see you thinking.
You can write it with a raised dot.
With a raised dot? What's another one, Tiffany?
Parentheses.
Parentheses, and what's our other one, Emma? X's. Great job. So now we've talked about our multiplication in our algebraic expressions. Now we're going to talk about another operator that we have, and that's division. So I want to see, Hannah, give us a try. How do you think we would read this one?
2x divided by 7.
2x divided by 7. Anybody think of another way we could? That's right. Anybody think of another way we can say that, Emma? 2x over 7. So there's multiple ways we can say that, but we know that whenever we see this bar, that means that it is division. But there's something else we can do with this because we know how to set up our division problems and do keep, change, flip, and how to cancel out all of our products and stuff like factors. So we could write this, if we wanted to, like this: 2 over 7 times x over 1. See how I use that raised dot there? It's coming off the board at you. But we could write this as 2 over 7 x. So just be aware of that when we're going through our homework, when we're going through different problems, that we could have different problems. So go ahead and open up your books. We're going to work on taking our multiplication and making them into parentheses or using raised dots. So go ahead and open your books and turn to practice problems 4.1. And I want you guys to do 1 through 6. And all you're doing is kind of separating them and writing them in different ways. I'll be coming around to see what you have. the desk. And then, yeah, once you get done, just stay up there so you can explain to us what you did. Hannah looks like she's ready to go with number 1. So tell us what you had and then what you did to show us our different ways of multiplication.
I can do a 9 times b with an x, and 9 parentheses b, and a 9 raised dot b.
Great job. Thank you. You can erase that and have a seat. Number 2, Anna Grace, what did you get for number 2? You're doing 2 different ways to do that.
I had 6 with parentheses B and then parentheses H, and then I had 6BH.
Great. Number 3, Emma?
I had 3 with a Y in parentheses and a Z in parentheses, or 3YZ.
Great. Hannah, go ahead and do number 4 for us.
You can do g parentheses h, or g raised dot h.
Very good. So you can see how Hannah's was a little different because she had to use that raised dot. So they're not always going to give us the same thing. Way to catch that. Good job. Number 5, Emma.
I did A, B, C, D, and A, B in parentheses, C in parentheses, and D in parentheses.
Very good. And then Tiffany, show us what you had so we can see it.
I had the 3 with the raised dot x squared, then times y squared, so I put it in parentheses, and then also just parentheses. So,
Right. Great job. You can erase that and have a seat. So it appears that y'all have that pretty well under control, how to write our different multiplication. You're probably wondering, why are we going over it so much? But that is one of the biggest things that we do in algebra, is have our expressions that are put together, and sometimes we have to write them differently so we don't get confused. But let me make a note of one thing for you, because I know that we just did a lot of our letters, we just went A, B, C. But let's just say that I have 2 times 3. Okay, we could write 2 times 3 with a raised dot. 2 times 3. We could even do parentheses. We could do 2 times 3. But what happens when I just put them together? We get a totally different number. We get 23, and nobody knows that that was ever supposed to be multiplied together. So when we have just numbers in a problem, you don't put them all together. You can use any of the other 3 forms, but don't stick them together, because then your answer will be way wrong when you really never meant it to be way wrong. So we have something else we want to look at with our expressions. And I know y'all have seen them before, and we've just been looking at one term expression. This is one whole term, okay? So think back maybe to your geometry that you've learned before, or that we even see this around in automobiles sometimes, or just different things. We have a bicycle. How many wheels does that have? 2. And then we have a tricycle. How many wheels does that have, class?
3.
Okay, so you kind of got it. We've got 1. Who knows what 1 is? Emma, do you know? Mono, very good. Maybe some of y'all knew that, maybe some of you didn't. So I'm going to write that up here so y'all can have that. So you're going to want to remember that mono means 1, bi means 2, and tri means what, Anna Grace? 3. Okay, so you're probably thinking, okay, we just changed gears completely. We're going to use that. So turn your attention with me over here to the sideboard, and we're going to be looking at a little bit larger algebraic expressions. So we have here, we have an addition sign, here we have subtraction, and we have an addition. But all of these fall under a certain classification. And these are, all of them are called polynomials. Poly means many, they can have different things. But we want to learn how to classify these based on how many signs they have. So how many signs does this have? Right here, class. 1 sign, but we have 2 terms. So here's one way I always remember to, so that I can get this right. So this is a binomial. I always take however many signs we have and add 1 to it. So we have 1 plus 1 more sign would be 2, which would make that what, class? If we have 2, it's a binomial. I know that's kind of weird. So this is classified as a binomial, okay? So you always take whatever you have. You can have one that's huge, count the signs, and add 1 more to it. And you say, well, why can't we just count the terms? Well, you could count the terms, but what about this? There's no signs. So it's still going to be you have to add that 1 more. That's why you add 1 to the sign. Because this doesn't have a plus or a minus. So you still have to add the 1 so you have a monomial. Because we don't have multiple terms. Okay, so this one we have how many? 1, 2. So what is this one going to be, Emma? A trinomial because we're adding 1 and we have our 3 terms. So I think y'all will be able to catch on to this pretty well. However many signs you have, just add 1 and that gives you your whatever classification it is. Now what if you have like 8? Okay, well we're not going to have an octopolynomial. I don't know how they do that. So at 3 it stops and we just have a polynomial. So right now we're just going to be looking at monomials, binomials, and trinomials and learning how to classify those. So go ahead and look at your practice problems again. 7 through 12, I want you to fill those out real quick. Look at those, count the signs, add 1, and see if it is a monomial, binomial, or a trinomial. When you are done, you can put your pencil down and look up this way. Okay, looks like everyone's almost done. Okay, so let's start over here and we'll go across from row to row to row. We'll start with number 7. What kind of polynomial was that? Emma?
Monomial.
The monomial. Number 8, Tiffany?
Trinomial.
Great job. Number 9, Ann Grace?
Trinomial.
Trinomial. Great job. Number 10, Hannah?
Binomial,
Is a binomial. Why do you think it's a binomial?
because it has 2 terms and 1 sign.
Right. There you go. Great job. You had it right. I just seeing if you knew why you had binomial. Good job. Back over here across the room, Emma, number 11.
Monomial.
And then the last one, number 12, Tiffany.
Binomial.
Binomial. So it looks like y'all all had that pretty good. Great job. So we just have a few things left. And sometimes you'll see things and it's written out in paragraph form and it's kind of like we don't have it in our exact phrases. So we might have something that looks like this. 6 plus y. Well, what's another way we could write that, Tiffany?
The number 6, the plus sign, and then the letter Y.
Right. So we could have 6 plus y. But because of our properties, can we flip that around and it stay the same, Anna Grace?
Yes.
So I could write or y plus 6. So we have a whole chart of those that we're going to work through, or a whole section that's going to tell you what it is. So I want Emma, can you come to the sideboard and do 16? I'm sorry, come to the sideboard and do 13 from those practice problems. Tiffany, you're gonna come do 14. Anna Grace, you come do 15. And Hannah, you come do 16. So you're just taking the words and putting it into form. Okay, stay up there, and then we will have you tell us what you did. Okay, I see some of you throwing those oars in there. Great job. Emma, tell us what you did on 13.
I did the number 6 and
Mhm.
plus sign and y, or you can flip it and do y and a plus sign is 6.
Great job. You can go ahead and erase that and have a seat. Tiffany, tell us what you had for number 13.
I did number 14, and it was 5a plus 4, or 4 plus 5a.
Great job. Looks good. Anna Grace, what did you have for number 15? You can erase that, Tiffany, and have a seat.
I did number 14, and I had 5a plus 4 or 4 plus 5.
Okay, you had that right. So go ahead and erase that, and we'll have you stay right there. And we'll have you do number 15. So I'm just going to read it out to you and see if you know what it is. Number 15, if I said y minus 3, how would you write that?
Y minus 3.
That's right. Great job. And then stay right there because I'm going to use that one for an example. I have another question for you, so just hang tight. Hannah, tell us what you had on 16.
I have x over 2 plus 3x.
Great job. That looks really good. You were the only one with a multiplication or division in there, so good job. You can go ahead and erase that. So everybody, look over here at Anna Grace's problem number 15. Now remember on our ones where we have plus, we did the or. Well, can we just go and put or 3 minus y? So go ahead and write what you would put for 3 minus y, and then you can have a C. Hannah, tell us, are those the same things like we did with this one?
No,
Why not?
because you have a positive 3 and a negative y.
Right. Very good. Does everybody see that? So make sure when you're doing your problems that you can only do that with addition and with multiplication. So let's just use these two same letters. Could we write 3y or y3? Is that the same thing, Emma? It is. Because if we wanted to do it, you would still get 3y or y3. You get the same answer. So let's look at division. Let's say we had, I said 3 divided by y. So I could write it like this, or 3 over y, or y over 3. Those are the same thing, right, Tiffany? No, they're not. You're a little hesitant. They're not the same thing because you're going to get you'll get a whole number with one of them and probably a decimal with the other if we knew what y was. So make sure you remember those properties that we learned at the beginning of the year when we're doing these, because sometimes it is good to rearrange them and to write them differently. So usually multiplication and addition, the same rules kind of apply. Subtraction and division, the same rules apply. So you can kind of put those grouping together, and we'll have a lesson in a few days where you'll see that division follows the same course as subtraction, and then multiplication will follow the same course as multiplication or addition. So we have one last thing to look at today, and you guys have been paying attention great, so thank you. Let's look at our last thing. So we've had all of these things throughout the whole thing, and we have failed to address one thing. We've had 3xy, we've had 4t, we can even have 91j. Hannah, can you give me one? It can have whatever you want it to have. Can you make one up for me?
35b.
35b. You know, I want everyone to feel special. Emma, can you make it? You've already made up one today, so make up a different one for me.
9p.
9p. Tiffany, do you have one?
10C.
10C. And Anna Grace?
20A.
20A, okay. All right, these are all, we're gonna use these to do some practice with. So we have all of these, and remember, what is this whole thing called, Hannah?
The term,
It is a term. What did we say it was at the very beginning of class, Anna Grace? She doesn't quite remember. Can you help her out, Tiffany?
an expression?
An expression, good. I was starting to get worried a little bit there. So we have all of these expressions, and we have constants and we have variables. What is our constant in this one, Anna Grace?
20.
And what's the variable, Hannah?
A.
Very good. So in all of these, we know that the number is the constant and the letter is the variable. Well, we have some other words for them. I'm just giving y'all a huge word bank today. So we're going to look at 3xy, and these are also known as coefficients. We have literal coefficients and we have numerical coefficients. Well, numerical, what does that kind of sound like, class? Number. So which one do you think is the numerical coefficient, Tiffany?
The number.
The number. So right here, it's going to be 3. Do y'all agree, class? Okay, this is our numerical. That looks really bad. And then xy is going to be our literal. Okay. So you'll want to keep those in your brains and use those in a few days. So we have our numerical and we have our literal. So each one has a leading coefficient, a numerical value. So in this one, what would it be, Hannah?
T.
So what is the numerical value of this one? The leading
4.
coefficient. It's the 4. Right, so in each one of these, we're going to look at these, and it's going to be the number. That is what is leading it. We know we have 91 of something, right? Because that's our numerical coefficient. So what is the numerical value in this one, Anna Grace?
35.
35. I know you're thinking this is too simple to actually be what she's asking for. What about in yours, Emma?
9.
9. And what is the constant in yours, Tiffany?
10.
The constant.
C.
C. And Anna Grace, tell me what both of these are.
So you have 20 as your numerical
Right?
coefficient, and you have A as your literal.
As your little. Great job. So you're going to be doing some of these. Go ahead and look. The last ones we're going to do, look at your practice problems 4.1 and look at 22 through 25 and jot down those real quick. It's going to be the leading coefficient. We won't go to the board for this one. It shouldn't take you too long to see those numerical coefficients there, numerical value. When you're done, you can put your pencil down and look up this way. You can please put that away. Okay, let's start with 22. Take it away, Hannah. What did you have? 4. Great job. 23, Anna Grace. 1. That was a tricky one. She caught that. We had just a plain XY, but she knew that that 1 is understood because it doesn't change the value. Way to catch that, Anna Grace. The next one, Tiffany, 24.
91.
91. We had one of those up here. And 25, Emma. 1. Emma caught that as well. Great job. You guys can go ahead and put your books away and take out your homework notebooks and write down your homework. Your homework for tonight is going to be sharpening skills. Excuse me, it's going to be sharpening skills 2 through 26 even. That's on page 111 through 112.